Hi, in this video, we'll pick up where we left off and begin implementing our block. So in the previous video, we implemented the storage, and this is the class here, the storage class. We are just going to minimize it so we can focus mostly on our block now. So let's do a quick revision of the whole idea of a block. So when you have a storage device, your storage device is your file system categorizes your storage device into blocks. So the block of the file, each block has an amount of data it can have. So this is five, and there are 10 blocks in total. So yeah, but your block can be different sizes depending on how you set it. So you can have a block of 10, but now you can have a block with size 10, but the amount of blocks you have will obviously reduce too. So when you're trying to connect blocks together, like I mentioned in the previous video, we use the link allocation. So the link allocation links one block to another. So basically, in many ways, a block is just a linked list. It has its data and the next a pointer to another block itself. So this is how we maintain our files via the block system. But there is actually something really interesting that I wanted to mention about blocks. So this is I mentioned. Let me just. Uh, so this is a hard disk, right? This is the plate in the hard disk. Hard disk is actually divided into blocks. So if you look over here, this is a diagram for the block. You see this place over here. Let me zoom in a bit. This is actually a block, right? So this is one block, this is another block, this is another block, this is another block. So even the hard disk itself has the concept of blocks. So it's one chunk of data is here. I think in the hard disk, I can't really remember whether it's 512 bytes, I mean megabytes or bytes for a block, but each part of the hard disk actually is separated into blocks. Okay, so let's begin implementing our block in Python. So first of all, I'm going to be using the data class to represent to create my classes from now on, and this is why. So if you're not familiar with data class just lets you define your class with respect to the data. So if you notice here in this storage class here, we had to define an init function, but with data class, we don't really need to define an init function. We just have to say what our data is, and the data class will just implement the remaining methods for us. Okay, so let's just dive in. While we are working on that, there should be a picture of the block by the side. So first of all, we define our block with a data class, and we define the data that are going to be present in our data class. And first of all, each block has to have an ID. So just like we have here, each of this block has a unique identification. Then the stats tells us what part of the storage device does this data begin from. So this first block here, which has an ID of 0, starts from this position here. Let's just call this position 1 to 5, right? So that's a start. So we can say, hey, starting point is 1. Then this second block here has an ID of 1, but its starting position is now 6. So we can say 6 to 10. This block here has a starting position of 11. We can say 11 to just 11. Then this, so they basically just have their starting position, and this is how we're going to know what area in the hard disk, I mean in the storage device we're getting. So you can actually see, yeah. So it's just let us know what part of our storage device our block is stored. So what we have to do next is this empty property here. It basically just tells us is the block empty, right? So if we look at this picture here, let me take it over here. This first block here has data in it, so obviously empty will be equals to false, but this second one doesn't have data, so empty will be equals to true. So that way we're going to know which blocks is filled up, so we can put data within it. So the next thing is, since the blocks are basically linked lists, we define what the next block will be. Like what is basically like a pointer. Does it have it? And it's optional. That's why I use this over here. Optional, saying a block might not have a next. It might just be on its own, right? Like take for instance this block here has a next, and that's the block with ID 8. Why the 8th block doesn't have any ID, it's just empty. So that's what the point of this next is. And the word optional is just for typing in Python, so we can know it. So let me import optional from typing. So this is our block, right? And quite straightforward to implement. And just like I said, the data class just lets us define this. There was no need for us to define an init function like we did over here in the storage. It's just quite straightforward than using trying to like implement classes, the methods from scratch. Okay, so let's just test out our block, right? So this file, the name of this file is main. So let me just import from main, imports block. Okay, so yeah, so now we have our block, and yeah, so let's create a new block. We just call that block B, or let's call it A, right? So we call the block A. Let's check all the properties our block can have. So we define it and say, hey, our block has an ID of 0. Let's just use this, an ID of 0. It starts from let's also say 0. We're using indexing here. Empty is equals to true, and next, we can just leave the next since it's optional. And watch this, we have a block, and we have this is one block, so we can create another block and the same thing, but let's just say this empty is equals to false, and this. So we have two blocks now. Now the cool thing about blocks is we can say a dot next, this is the linked list, is equals to b. So now if we check a, if we print out a, we realize that a's next block is the b block over here. That's b that has an empty equals to false. So this is the foundation of how our files will be implemented, by using blocks as our nodes in our linked list. So in the next video, we'll begin working on the file system, the file class, the file system class, and also the file class. So this is where we're going to pick up from the next video. Thank you.